Mechanical engineers typically design towards certain velocity and friction ranges within the ducts and pipes in an HVAC system for optimal airflow or water flow within them. These inform the duct and pipe sizes. There are numerous duct and pipe sizing tools, but Revit has integrated features for sizing ducts and pipes for HVAC design. In this video, we'll explore the various approaches to sizing ducts and pipes in Revit, the manual method, and the duct and pipe sizing tool. So start by opening the file you used in the previous video, or duct and pipe sizing in the chapter 4 exercise files folder. So at this point, launch Revit, navigate to the exercise files. From the chapter 4 folder, open this file, duct and pipe sizing, which I have here. Then open the ground floor duct legend plan, which I have open. Our target values for this project are: for ducts, we want to achieve a friction of 0.6 to 1.0 Pascal per meter and a velocity of 2.5 to 7 meter per second. For pipes, we want to achieve a velocity of 0.6 to 1.2 meter per second. So when you select a duct or pipe segment, you will find the read-only mechanical flow information on the properties browser. So from here, you can see such information as the flow within the duct, the velocity, the friction factor, the friction pressure drop, and whatnot, which are most read-only information. Now, if we change the size, you notice that these values will update in real time. So let's say I change the width of this duct to 500. You see they all recalculate and update in real time. So the size informs all these properties. So because of that, experienced designers and modelers look at these values when laying out duct and pipe networks in Revit. Now, if you recall in the previous video, this is one of the shortcomings of the automatic pipe or duct routing in Revit, because it doesn't give you the opportunity to resize the ducts as you lay it out manually. But Revit has the duct and pipe sizing tool that makes it easy to size multiple ducts and pipes together. And that's what we'll do next. But before we do that, let's tag the ducts and pipes so we can see the sizes. So go to the annotate ribbon. From the tag panel, launch the tag all button to launch this tag or not tag dialog. Then tag all the ducts in this view by clicking this and then click OK. So this will tag all the ducts in the view, as you can see here. Also quickly repeat the same for the first floor. So go to the first floor duct legend, then click tag all, select duct tags, click OK. Now for pipes, we'll duplicate the floor plans 4 times for the supply and return, chilled and hot water loops. I've already done that ahead of this video to save time. Now for each of the view, I've applied view filters to show only the net pipes. So when you open this, you can see that this is chilled water return. So for this view, you only see the chilled water return pipes. So I did this by creating view filters in Revit. When you go to the view ribbon, from the graphics panel here, you can create filters. So you can see that this chilled water return basically says that the system type equals chilled water return. Now I created all that filters and then I went through the visibility graphics and I applied the filters to this view. So when you look at this, you see that the only visible pipe you have here is the chilled water return pipes, which means their system type equals chilled water return. So I've done that for all the views. So we need to quickly tag all the pipes in these views. So go to the annotate ribbon again, tag all. This time select pipe tags and then click OK. So you do this for the 8 views I've created. So now we'll go back to the ground floor duct legend view. Then we will tap the tab key once while hovering over one of the supply ducts in the guest room. Tap it twice to select the supply duct layout for the air system here. Then click the duct and pipe sizing tool from the analysis panel here, and this will launch the duct sizing tool. So there are 4 available sizing methods from this drop down. You have friction, velocity, equal friction, and static regain. You can also combine velocity and friction. You can satisfy the two values by clicking and, or you can satisfy one of both by using this or this. You can always switch this to friction as well and do that. Now for this project, we'll set the sizing method to equal friction, and we'll set the value to 1.0 Pascal per meter. For the branch sizing here, you can set the duct sizes to calculated size only, or match connector size, or use the larger of the two. For now, we'll match the connector size since we've already set that for our components. You can also restrict the duct's height and width. So after this, you simply click OK, and Revit will take some time to resize the selected ducts. Now, looking at this, one of the first things you have to do is to still manually resize the ducts and flexible ducts to ensure they are commercial sizes. They are easy to fabricate. Now, when doing that as well, you need to keep an eye on the velocity and the friction values in the properties browser. And also, when you look closely here, you see that this doesn't properly connect. So in some cases, you might also trim some branches depending on the impact of the ducts and pipe sizing too. So I can select this, and then I delete this. Then I go to the modify ribbon, use the extend trim tool to trim this properly. Now I can flip this to face the right direction. Now looking at this, if you select this pipe segment, for example, when you check the flow information, the mechanical flow information, so from here for this project, our target, like I mentioned earlier, is 2.5 to 7 meter per second for velocity and a friction of 0.6 to 1. So when you look at it, you see that this is within range. However, this duct size that we have here is not a standard commercial duct size. So sometimes you might use this as an average. So what I can do is I can take out 25 millimeter from one side and add to the other. So for example, I can set this to a width of 200 and a height of 150. And then I can also do the same for the elbow. So I can either select the elbow and you can also set the width and the height, or sometimes I prefer to just delete it and trim these two ducts once again, and Revit automatically connects the two duct segments. Now when you select this and check the values, you see that the friction is still within range, which is 0.6 to 1, and the velocity is still within range, which is 2.5 to 7. So we can quickly do all that and make sure that these ducts are standard sizes. So I will start from the first one here. So when you select this, see that this is 275 by 275. I can change this to 300 by 250. And of course, I confirm that it is within range. So of course, you can use the duct tag to make sure that it's correct. So you can see this is within range and this is within range. Now this one, this size looks okay, so I don't really need to resize it. I can just confirm that it is within range, which is fine. And finally, I have this two here. So when I select this, I can select both and I can set the width to 150 and the height to 100. So you see the tags update in real time. Let me just trim this first. So when I check the flow information here, you see that velocity is within range, but now the friction, maximum friction is 1. So this is slightly out of range. You can also set this to a similar value, 150 by 100. So in cases like this is a bit of a dilemma. In a real project, you can either choose to use a non-standard size to make sure that you are within range, or you can also add some other components. For example, you can add a damper to make sure that there's no too much friction here, because when you have too much friction, that can lead to noise in the system. We'll still look at that in a future video. So this is where analyzing all the segments of your duct layout comes in. So with this, the entire layout looks fine. It's only in this area that is showing red that will have a bit of more friction. Also, when you select the flexible ducts, sometimes you might also notice that they are out of range, but then you have two options here. If you want this to fit in properly, you can either increase or reduce the neck size of your air terminals, or you have to cushion the effects of maybe too much friction or too much velocity. The velocity here is slightly out of range, is 2.5 that we need, and the friction is actually correct. So this is actually fine, but in such instances, you either increase or reduce your neck size, or you find something else to join both of them. Now we can quickly do the same. This one is pretty straightforward. So just double click to select the entire layout, and then we just use the same settings as before, and now click OK. Now already by looking at this, you see that we can just match most of this with this, which is 300 by 250. We don't have any branch, so we basically use the same size for most of them. So we can select the 3 duct segments and set them to 300 by 250. And then we can just delete these 2 elbows and trim the segments together. So now we've taken care of this guest zone. Now in practice, we realize that it's often more efficient to resize portions of your duct or pipe layout using these ducts or pipe sizing tool instead of resizing the entire layout. So instead of using the double tap of the tab key to select the entire layout, you can as well just tap once to select a portion, or you can even just select just the ducts and you resize it. So in practice, you realize that it's often more efficient to just size a small portion than trying to resize the entire layout at once. Now that we've configured this zone, use a similar setting to resize the ducts for the other supply and return air system across the building. And when you're done, you want to use the system browser. So enable this system browser and make sure that there are no extraneous systems, because sometimes by the time you start creating new ducts and pipes, Revit might go in here to create some extra system. But looking at this, this is fine because we have 11 zones, so 11 supply, 11 return, which is okay. But when you're done, confirm that it is fine. Now another approach to make sure that all your duct systems are fine when you finish laying out is by creating a schedule. So you can create either a duct schedule or a flexible duct schedule to overview all the duct layouts in the project, but we'll still look at schedule in more detail in a future video. Now the manual and the automatic methods we've used for ducts also applies to pipes. So like ducts, like I mentioned, you want to use the tab key to select a portion of the pipe layout and launch the duct or pipe sizing tool. So just to quickly show you how that will work, if I go to the chilled water return pipe view here, I can use the tab key, maybe tap once or twice, or I can still even select the entire thing by tapping 3 times. Then I go to the duct sizing tool. Then I can, in this case, for example, I can set my velocity to 1.2, which is the maximum I need for the pipe systems, and I can match the connector. So just the same process, you click OK. Now if you look at this, we've selected almost 1,000 elements, so that will take some time to resize all of that, but that is also how you can use this to resize your pipes. And when you're done, you might still need to select the pipe segments and change their sizes to standard commercial sizes. So while you're doing all that, always look at your system, your properties browser, to make sure that the velocity is within range. So that's it. You can now size the ducts and pipes in your projects based on defined constraints. In the following videos, we will still explore even more systems analysis tools in Revit.